So, I just went online and found a slide deck about perimeter security and added a few things to it. That's the topic here. This is actually very important, of course, for something like the CCDC, because the point of that is you're going to have a network and you are going to have people owning it, connecting over the network, messing with your stuff, and you're going to have to recognize that and block it. And I don't really know what the best product is to stop an attack in progress like that. I would think the simplest thing to do is just put in a firewall rule blocking the IP, but there may very well be better solutions. I know enterprise class stuff gets very good. Like I mentioned before, I had students go to their bank and try to do their hacking homework, which was not something I recommended. And when they download something like Kane, the phone rings immediately and they say, what are you doing down there? Knock it off. So you want that. Something will just pop up. Wait a minute, this looks bad on the network. Poof. No, none of that. And that's not as simple as just a firewall. But anyway, one thing that all the people talking about CCDC have talked about is that you end up stuck with some old operating system just the way it is, and you don't have any time to prepare or install new stuff. So the main thing you have to do is you have to know how to use the existing stuff. So anyway, all right, so the perimeter is originally, like before 2002, this was Microsoft's recommendation, and it was common back then, that your primary security is at the edge of the network. And you have this thing called the trusted inside, because all the machines are big, heavy machines on tables, and then you have the dangerous outside, and you imagine that inside is much safer than outside. Yeah?
Are these sites made available?
They're already on my website, yeah. Yeah, that's fine. Anyway, so the this is arguably completely over. Now every perimeter is porous, you have wireless networks, you have people bringing in laptops and phones and everything, and your illusion that the inside network is more trustworthy than the outside is hard to sustain. But people still stick to it, and one of the really stubborn parts of this is people refuse to secure their layer 2 infrastructure, because supposedly no one can get in the room unless we trust them. Yeah. You can plug in, you can connect with wireless, you can click on these things and download malware, your printers can be infected.
Wireless printer, people don't turn off that function.
Yeah. But I mean, it's anyway, so there is a perimeter, you got routers on the outside, and you got firewalls on the outside protecting your whole network, and then you got intrusion detection system and prevention systems, hopefully limiting some of the attacks. You also have people on the outside that are really on the inside coming in through VPNs. And you need that or you can't get anything done. So, all right, so your border routers is your first layer of defense. If someone takes over your router, they can, of course, control downloads and alter things, and we just had the NSA's files for this dumped a week and a half ago, and you can see they totally do find vulnerabilities in routers, install malware, routers and firewalls, and then sniff everything. So the firewall is probably your main thing that's going to protect you. If you deploy a server with no firewall at all, then your people can trivially start listening on ports and the traffic will get there. So almost nobody would do a thing like that. Typically they use routers and the access control lists in the routers and the firewalls to limit and channel the traffic. So you might have the internet. See if I can find a pen that works. So you have the internet, and then people are coming into your network. You have a firewall here, which only lets through the ports of interest. Then you have the border router. Then you have servers down here, and you'll have something like the web server here, and then you'll have the database server over here, and you will have your routers and switches configured so that no traffic from the internet cannot directly get to the database server. It can only get to the web server. There's another gateway here, another firewall or something. So this is your DMZ, where you have less protection and you have more protection over here at your database server, and the only thing that can talk to it is the web server, fetching data, and therefore attackers cannot directly attack the web server, the database server. They have to first conquer the web server and then pivot to there. And that's what people do, but it slows them down and it gives you more chances to catch them. Yeah?
Why do you call it the DMZ? Because I think of DMZ as demilitarized.
That's what it is. That's the idea. The DMZ is like if you have a military base, you clear the brush for 100 yards around, so people are trying to sneak up, you can see them. Right. And that's what this is, the same thing. On the outside of your network, you have a less trusted area where you know the whole internet is in here, and your web server, email server, and then you have another filter here. So you're aware that worrisome strangers are here, but you have another layer of inspection before they get into the entrusted network. It's the same principle. Yeah?
Is filter and firewall used interchangeably?
Technically, a packet filter is a generation 1 firewall. The first firewalls just did filtering, which means they look at each packet one by one with no memory, and they just have simple rules, usually looking only at the packet header. So the only thing they filter on is IP address, whether it's coming in or out, and port number. That's the very simplest kind of firewall, and routers can do that. But they call those things, those are generation 1 firewalls. Then firewalls got more sophisticated, and that's right that's a static packet filter, what I just talked about. The next step is a stateful filter. Every computer has a state table, so this is going to have to be running on a...
Is that more like IP tables?
IP tables is a stateful firewall, yes. And so if your state table is here, you do netstat -an pipe more, and it's exactly the same command on Windows and Linux. And it shows you this. These are the sockets. You have a local address and a port number, and you have a remote address and a port number. Those 4 numbers are called a socket, and that makes a two-way communication channel, so one process on my machine can talk to one process on the server as if we had our own cable there, and it has states. This is established if it has done the SYN-ACK and is transferring data, and it has not been closed with a fin or reset, or from a timeout, from inactivity. So these are browser windows that are still displaying ads or something. And so these are established connection. Here's listening port for incoming connections. By the way, this is one of the things you'll see is listening only on 127.0.0.1. So it's listening on the network port, but no traffic can actually reach it, except traffic from the same machine. You can have 2 processes on your own machine talking to each other through the networking without going out the NIC by using a root back address. And what's that?
That's localhost.
That's localhost, yeah. And this is, I don't know why so many people do this, but it's especially Windows. Since Windows Vista, if you do this on a Microsoft machine, there will be about 20 of these 127.0.0.1 things listening on 100 ports and connecting. And I've been trying for years to get anybody from Microsoft to tell me what those things are. But for some reason, well, but there are listening, see, that's why you know this can't be a backdoor, because it's only listening on 127.0.0.1. Now, if it was listening, this one, here's the IP version 6 version, ::1 631. If it's only listening on 127.0.0.1, it can't be a backdoor, because no traffic from outside the machine can reach it.
Because it's in the back.
Yeah, it's only listening on 127.0.0.1. Now, if it's listening on 0000, that's all addresses. Or on your address here. Yeah.
Well, let's say it's listening.
Yeah.
And it's shuffling all this off to a hidden file.
Yeah.
And then something else is attacking it to get that access to that file.
Yes.
So they can get key logs, files, whatever.
Yes, it could be a keylogger. It could be doing something locally, but it can't be connecting to an external device, not directly.
Right.
So it may be evil, but it's not a backdoor in the usual sense. It's not the way
But
someone
if
can
I'm
do
going to
it.
attack your machine,
Yeah.
and I know this thing is on every Microsoft machine, guess what? That's the honeypot.
Well, possibly. But anyway, that's what's going on here. Here's one, star.17,500 listening. That's listening on all addresses on that port. So that could really be connected to from outside. And all right. Anyway, so there's these states, like close, wait, and listen. And so a stateful firewall can filter packets based on information in the packet and on the state. And the most common arrangement, which you can do with the uncomplicated firewall in Linux or with the Windows firewall in Windows, is you make yourself a client only. On a Windows machine, you choose a location, and if you tell it you're in a public location, the default firewall setting is to make a stateful firewall, and the rule is anything originating from the outside is dropped unless it matches an established connection. So you can use the internet. You can be a client. You can send a SYN out to anybody. And when the SYN ACK comes back, it'll go through, and the ACK will go through. And after that, you will now receive traffic from that IP address and port because you have established a connection that you asked for. But if somebody sends a SYN from the outside on any port, it is thrown away. The only SYN that you'll accept packets from are established connections, and that means you can't be a server. If you run a print server or something and people try to connect to the printer, they won't get through the firewall. That's the point of it, and this turns out to be extremely effective. A Windows XP, no service pack machine connected to the internet will get infected usually after 1 day. And if you put on the Windows firewall and nothing else, it takes 1 year to get infected. So I mean, this is actually enormously successful at preventing a lot of attacks. Anyway, yeah.
Defender's the one you're
Windows Firewall?
No, Windows Defender is their anti-spyware product and a weak kind of antivirus. It's called Windows Firewall. And we got some pictures coming up.
Okay.
The firewall is a separate thing. Firewall just affects network traffic. It doesn't have virus signatures and such. Windows Defender does. Anyway, all right. So let's see if there's anything else worth mentioning here. So Cisco routers and stateless firewalls are just obvious things, like things coming in on ports that you know are evil. Most attacks sneak in on ports that you're letting through. All right. So here's the Windows Firewall. If you type firewall into the Windows search panel, you have two panels. This is the easy one to use, and that's the more complicated one. Yeah. What's that?
Is that Windows 10 or Windows 7?
This is Windows 10, but it's the same in Windows 7, and even everything since XP Service Pack 2 has worked this way. Windows had a different firewall before XP Service Pack 2, which I hope you don't have to worry about. I hope they're not going to do that to you. But back then, the firewall was essentially useless because it did not have different settings for each network adapter. So whatever you set applied to all your network adapters, which was very frustrating. So it was essentially useless, and at that time everybody would download stuff like Zone Alarm Firewall because the Microsoft Firewall was no good. Now, the Microsoft Firewall is really quite good. It's got the simple panel here where you can just turn it on and off, and you can choose public networks, private networks, and home network. Private and home are the same as far as the firewall is concerned. The only point of a home network is you can have a kind of file sharing called home groups, which are not very important and not usually used in an enterprise environment like a domain, so you probably don't have to worry much about that. But you do need to know where you are. You have separate firewall settings for public and private networks. And in the private networks, the firewall does allow your machine to be a server. If you've turned on a listening service that Microsoft knows about, like file sharing, it will let packets through on that unsolicited incoming traffic to get to the file share if you're on a private network. If you're on a public network, it will block all that, so even if you have a listening process, it will never get any traffic because they assume you carried your laptop into a coffee house and you don't want anybody accessing your shared files and printers in there. And if you want to really get into it, so these are the profiles, domain, private, and public. If you're connected to a domain controller, the domain profile is active, which in principle can be pushed out from the domain controller as part of their security policy. If the domain controller doesn't specify it, I think it amounts to about the same thing as the private profile, but I'm not quite sure. And if you go to the firewall with advanced security, you get a GUI that gives you hundreds of rules for ingoing and outgoing traffic, and these are very sophisticated. You can tie certain programs only allowed to receive the packets. You can specify all sorts of parameters here in these rules. This is what I would do if I was in CCDC and people were taking over my machine, is find their IP address and put a rule here that blocks their IP address. That would be a simple way to stop that connection. Now I know we've heard the red team guys talk about this, that they of course aren't going to let that. All right, guess it must be my phone on. Anyway, yeah, it's probably mine. Anyway, so yes, I'll find it and turn it off. Usually I have this sound off, but for some reason I must have actually expected a phone call at some point. Anyway, if you ever want to reach me, calling me on the phone is essentially useless, as you can see. I tell people emailing me will reach me faster than the phone, and they don't believe me, but it's true. Anyway, Anyway, this was one way to stop attacks, but of course, an intelligent attacker will go through Tor, and I think the CCDC people said they had their own version of that, where they have a whole series of addresses and they'll just hop to another address, and so you have to block them all, or, and that's what Bro can do. Bro can notice attacks and block an IP address automatically, dynamically, and then if they change to another address, as soon as it recognizes an attack, it'll block that one, and that would be useful. But I don't think Bro is probably a reasonable option for CCDC. But anyway, it's a good thing to know about. So as I say, NetStat is your friend in both Linux and Windows. NetStat minus AN pipe more gives you all the ports listening, and the N means it shows you numbers like 80 and 443 instead of trying to interpret those as letters, which is very annoying because it doesn't just do it for HTTP and HTTPS. It'll take all the other numbers and turn them into meaningless alphabetical acronyms so you don't know what you've got. But anyway, this is how you can see all the current connections, and if somebody's remotely controlling your machine, they're probably in this table. Now there is malware, like rootkits, that will hide things in this table where you have a network connection and you can't even see it. And that's tough. So I mean, you can't, of course, if you're running anything on a compromised machine, you can't really trust it to be reliable, but most things are here. The same thing's true of DIR and Windows Explorer. If you start hunting for files in your system, if you have a rootkit, you can't see them. There's another folder you can't see and files hidden in it. But you know, there's not much you can do in that case except run special rootkit finders. And they said that, with the CCDC people talked, and they said that they do have an archive of ISO images in case you just want to rebuild your system from scratch. And that's probably what you want to do if you get a rootkit. But anyway, so Task Manager is another place you go. You go here to see what's happening on your machine, and it will show you the processes that are running, and it will show you which processes are using network more. So that might be one way to help. This is one way to see which processes are having network activity. And Resource Monitor, which you can get to from Task Manager, is another one that's really very nice. This gives you the stuff that used to only be available in the command line. One of the great things Microsoft added in Vista. So you have a list of all the processes with network activity, and then you have all the TCP connections here in a graphic interface, and then you have all the listening ports. This is really very nice if you want to hunt through and see how is someone getting network traffic into my machine and controlling it. All right, and I mentioned in Ubuntu, you can put in the uncomplicated firewall in Ubuntu, and this is like the simple pane for Windows Firewall. If you enable the uncomplicated firewall, it now does exactly what the Windows Firewall would do. It blocks all incoming traffic that's not part of an established connection. So you're a client, but not a server. And in fact, you can see it, all the uncomplicated firewall is doing is putting rules in IP tables. IP tables is the standard Linux firewall. It is fantastically powerful. One of my students that works at Cloudflare told me Cloudflare does all this fancy stuff, the diverse proxies and everything else, and he said they tried installing a lot of software and they finally realized just use IP tables. It can do everything. Every possible advanced feature you want is in there at the cost of it being pretty hard to use. These long command lines with complicated switches, and people complain a lot about it. And most of the tutorials are 20 pages of baffling complexity, but you can do simple things with it. But that's why they invented UFW. UFW is the easy way to turn it on. Here's IP tables. So if you clean out your IP tables rules, there'll be nothing in there like it is down here, and you add things like this. This is one I do a lot in the projects. This is the command to drop reset packets. So there's a table, there's an input table, a forward table, and an output table. And you can use the forward table to forward to other processes. Use your machine like a router or a proxy. And you can, this one here, it's the output table. This will stop your machine from sending out reset packets. This is important in my projects because if you try to use direct packet manipulation and do a TCP handshake by hand, the operating system will resist this. The operating Windows blocks it very sternly, and Linux blocks it with less seriousness. But the point is, they think the only way you should make a TCP connection is to ask an operating system routine to please negotiate this connection for me. And if you send out your own SYN packet, it will say something, not me, is sending out SYN packets, and it will send a reset saying go away. I don't want that happening. And this is one way to stop it, where the operating system will continue to send resets and try to tear down these unexpected connections, but you block them at the firewall so you can in fact make your own TCP handshake. They call it raw packets.
Then you're adding a rule, right?
Right, yeah, that adds a rule. And now it's down here, where it's going to drop flags that have reset. So that outgoing traffic with reset will just be dropped and not actually make it to the network adapter. Yeah?
Can we do the same thing except in reverse for ARP spoofing? Except instead of filter all outgoing reset, maybe filter all incoming?
You probably could, but the problem is, if you were to filter incoming ARP replies, you wouldn't be able to use them and get your own networking. So what you probably would want to do would be to filter all incoming ARP packets except the ones from the router. You know, then you could only, actually it's not easy. Now, if you have like an intrusion detection system, you could notice if you're getting a lot of ARP responses, because typically ARP poisoning, they send like an ARP reply every second from the same address, and you might be able to notice that. But there's a lot of ARP flying around the network anyway. It's, the only defense against ARP spoofing that is easy that I know of is Decaffeinate ID, written by IronGeek. It runs on Windows, and it's a log monitoring tool. It notices your ARP table. If your ARP table is just changed, and the IP address is not changed, that's a pretty clear clue that someone's lying to you, unless the coffee house just bought a new router right now, somebody's spoofing ARP, and it pops up a box warning you this is happening. And that seems like the place to go. This, by the way, I think for CCDC and also for incident response, in the other class, it is real important not to bother doing things that are hard. Go for things that give you the right answer fast, like a log, as opposed to hunting through disk images and complicated things. That's the way to really efficiently deal with things. One of my servers was hacked a couple days ago. Now I have these attack servers that are there to be hacked by students, but somebody actually hacked it and put a malicious tool on it and attacked somebody with a brute force attack, and my hosting provider shut it down. So I went on there and I realized I didn't have an easy way to find it, so I put on Tripwire. And I have instructions, like I say, I highly recommend Tripwire. Tripwire is easy to put on Linux systems. It's free. There's also a commercial product, which is big and fancy and expensive and runs on Windows and such, but the Linux version of it is free, and it just gives you a simple list. In fact, let me just show you, because I did this for my honeypots and now I'm doing it for my normal servers. So if there's somebody has not hacked it again in the last day or so, good, it's still up. So here's attack32.samsclass.info, and I put Tripwire on here, and I can show you the result. It's actually very easy to put on, and I made 3 little interfaces. I wrote a cron job that gives you some results from Tripwire. So here's the current. Right now I have 16 violations. I had 6 before, so something has changed on this machine. Here's at this time. So every time I run Tripwire with a cron job every 10 minutes, and violations are files that have changed. Now, when you first install Tripwire, you do tripwire --init, and that measures the current state of every file and puts it in a table. And then anything that changes from that point on is a violation. So there's always a few. So I did a couple more commands after that changed a few things. So 6 is when nothing bad has happened. Those are changes I made, but somebody else made another 10 changes here, 15 minutes after I was last on there. That might have been me again, I don't know. But if I want to know what they are, here's the Tripwire report. And that's why I highly recommend this thing. This gives you something simple that is not too baffling. So it gives you, here's the policy and configuration file names and such, but here's the game. Here's the Unix file system. It checks all these objects, and here's what happened. These are my crontab scripts. The way I'm using crontab, I highly recommend learning cron. Cron is a really old Linux utility. It's in everything. It's even in the Raspberry Pi. The command that controls it is crontab. It does any kind of scheduled jobs. There's the simplest way to use it, there's just a folder called daily, hourly, and weekly. You can just put a script in there and it'll run then. But I do it with custom things. I can adjust. You can run anything on a periodic time. And what I do is I run a script and then I just modify the script to do everything. So this is the thing that runs every 1 minute as root, this one, and this is the thing that runs every 10 minutes as root. Tripwire is pretty heavy. When it runs, it will consume like 100% CPU for maybe 30 seconds. So don't run it every 1 minute. So I run it every 5 or 10 minutes or every hour. Production servers typically run it like every day. But it is a good idea to run it on some basis. And here's what it'll show you. So here's what happened. Somebody modified my Docker and my mtab, which is a little strange. They modified my AppArmor cache.
mtab is where all the file systems are mounted on the...
Okay, so but the fact that it's messing with AppArmor is something I learned about accidentally on Linux. This is something that came from SE Linux. In Ubuntu Linux, AppArmor is turned on by default, and that means each application is limited in what it can do, like where it can write folders and stuff, like a working directory, as if it had its own account, which it doesn't. And you have to adjust it in AppArmor if you want to use an application to write in strange places. I keep having to do this because I write web pages that are then going to write files in a temp folder and here and there because people are supposed to play hacking games, and I keep having to disable AppArmor to make that possible. So there's another layer of security there, and I had to Google AppArmor, and I frequently have to turn it off to do the goofy hacking things I'm doing. Then somebody messed with my grub environment, and somebody was using Nano. So it might be interesting to see what's happened here. You know, so this is a whole lot better than just having a file system and a complaint letter saying what happened. Here you have a pretty good clue where you might want to look to see who's been doing what to my machine.
Yeah, you should track where it's coming from right now.
To track where it's coming from, I don't have a way to do that here. I don't think you can do that in Tripwire, but you can do some of that in Apache. And I haven't figured out how to do that here. I did it I couldn't find my notes, so I was getting tired of this, but I wanted to enable Apache forensic logging, which stores the complete URL and IP address of everyone that connects to your web server, and that's good. By the way, another thing you should do, which I haven't done, is use something to monitor your Nagios, to make sure that your servers stay up. Let me just add that to my links here. We should definitely talk about that in this class. Nagios is the...
I've used OpenMS
Yeah.
Another one.
Yeah, there's also smoke ping, but anyway, here's Nagios, and I think I'll just go here and put it in the links. There. Yeah, just like this is what a lot of people really use. It's again Linux-based, a little hard to set up with config files, but the point of this is it tells you if your services are up. It will test: is the web server up, is the email up, and it'll do anything you want to inform you, like send you an SMS. Oh my God, the server just went down. This is the difference between getting fired and keeping your job as a server administrator. Because if your web server goes down, you are supposed to call your boss and say, the web server went down and I'm working on it. You don't want to have a customer call your boss and then your boss call you and say, why is the web server down? And you're like, oh, web server's down. Gee, I don't know anything. This is not a good move. So this thing is pretty good to use, and I'm going to add it to this class and we'll talk about it. But we definitely should play with this and then make a good project, which we'll talk a bit more about later. But I should really be running this so I know when my servers are down, and I'm not. And so I'm that dunce server administrator at the moment.
So this guy
Yeah.
that's attacking you, Nagios, will give you more information?
No, it would tell me whether my servers were down. So it would alert me that a bad thing happened, which is a clue. But to find out more about people coming in, the first thing I'm going to try is Apache forensic logging. Now in the past, I would save all the PCAPs with TCP dump. And that was really big, and it was really hard to go through. That was the kind of thing I don't recommend that gives you like a 10 megabyte file full of complexity to figure out. What I'd rather have is a log with IP addresses of each connection that I can quickly scan through. And that's the trick, is to find the things that give you useful information fast and don't just waste your time with another research project when you're in the middle of trying to stop an attack. All right. So intrusion detection systems are the things that we'll be noticing what's coming in. Snort is the standard, and probably if I put Snort on the server and turn on Snort logs, I could get a pretty useful list here. I haven't even done that, and I probably should. Anyway, Snort is not only free and simple to use, it also has the standard for network signatures, which is used by everybody. And other products use Snort signatures. They have a sort of grep type format to describe a network packet. And anyway, that's the game here. There's network-based intrusion systems and host-based intrusion systems. The network-based ones have only access to the network traffic. And these days they can detect established connections because they just watch for the SYN, the SYNAC, and the ACK and keep track of it. But they don't have access to your local server logs and such. So things like Tripwire are actually looking at the file system. What Tripwire does is it just calculates a hash of every file and stores it in a table. And then every time you run it again, it recalculates the hash of every file in the folders you choose to monitor and tells you if any of them changed. That's why it can do it. And that's the kind of thing only a host-based IDS can do. And Tripwire is not watching network traffic, it's watching the file system. But Snort would watch the network traffic, and that's definitely something to get better at. I've only know the basics of Snort, but I should probably stick it on my server too, and a Snort log would be good to answer like who is messing with my app armor. That doesn't sound good. I should probably find out which IP address is doing that and block it. All right. So that's the game. The IDS has a list of malicious signatures, and every time there's any kind of network attack or new attack, people immediately write a Snort rule, and they put it in the Snort forums, and people that get into it, they get a lot of rules from there, and that's how you keep up to date on the latest things. The reason why these things are so popular is that you don't have to wait for the manufacturer to put up an update. Like, there's problems with Microsoft, maybe they aren't going to patch it for a while, you put it in the signature, you have another layer of defense you can easily control, and putting some kind of signature on your Snort rule is not going to break the OS like the Windows patch might. So it's, that's why layered defense is so much better in a lot of ways. Anyway, so there's a project here where you do the simple things with Snort. You might start there if you've never used Snort at all. Here you get Snort running with its default rules, and that will detect things like Nmap scans. And then there's a whole bunch of other rules you can turn on. So I put it in this link per one for perimeter if you want that. So an IPS will automatically detect an attack and stop it. Snort usually just logs it, doesn't usually stop it. IPSs will not only detect it and log it, they will then adjust the firewall rules to block it. And that's something like Bro would do.
Bro's an IPS?
Yeah, Bro is the one from UC Berkeley, and it is considered very good, but it's hard to use. Until about a year ago, the official Bro documentation said, if you want to learn how to use it, just grep the source code. I'm like, dude. I'm like, you've got to be kidding. Now people are beginning to like write documentation, and give you like virtual machines you can install that have it already running. So basically nobody could use it except the people that made it for a while, and they're finally coming out of the closet and having a product that normal humans can use. People say it really works, but you know, that is the ultimate geekdom. I mean, I've been mad at open source projects that don't have a clear explanation of what they do, but that's the worst I've ever heard. They don't even write documents. They think every user is just going to read source code.
Is there a video they made? No?
I think now there are some videos, and I think now using the proper documentation. I know the similar product was Nginx. Nginx was the super fast web server, and until like 5 years ago, all the documentation was in Russian. But I think it's getting better now.
Used to be light HTTP. Lighty?
It might have been. Well, also I've heard that it was originally written by criminals to control their botnets.
What, NGX?
No, Nginx. Nginx was, and that's why they had to make, what it is Apache, with 90% of it thrown away to make it faster. And that was the point, because Apache can't really handle a whole botnet worth of traffic. That's why if you see things like the anonymous attack on Sony, there are logs from their IRC channel. They tried to use an IRC server to control a botnet of about 50,000 machines, and it totally didn't work. And so the IRC channel is awful. It dropped me again. The attack stopped. Who wrote this crap? Why isn't it working? That's what they're all saying as they attacked Sony. They took it down. Enough of them got through. But if you don't have a high capacity server running a botnet, it doesn't work. Anyway, all right. And then virtual private networks are how you let the good guys in. In the incident response class, we were talking about the target hack, I think, a case history from Mandiant. And there, the bad guy got in because somebody clicked on a link, and then installed malware on that machine, installed password hashes, and eventually got a domain administrator password, installed the domain administrator passwords, and then they had the developer's real name and password for the VPN system, and after that they would log in with real developers' names and accounts. And the way they eventually got caught is somebody noticed Bob is logging in 2 places. One is like in our city, and the other is in like far away in Texas at the same time. That's not good. And then they changed Bob's password, and so he just moved over to Mary's account. He had a bunch of accounts, and they said, man, we better call in consultants because we've been hacked. This guy has seriously owned us. Anyway, and that's the game here. VPN will let in outside users. You definitely would be wise to have 2-factor authentication on this, so they can't just steal a password. They should have a phone app with Google Authenticator or a RSA token or something, because otherwise anybody can steal that password and get in. Yeah?
Yeah, that's what they did, the post office hack. They stopped all the VPN outside, and they had to issue tokens before you let them back in.
Much better. 2-factor authentication is where it's at, because that password is stored somewhere, and sooner or later someone's going to get it. Some clown is going to use a password of 1, 2, 3, 4, 5, 6. You know.
Also, the token doesn't have the full code.
What's that?
The token doesn't have the full code. Because part of it's the employee ID.
Oh,
So
well, that's not bad either.
on there,
Oh.
so if they got that, they still couldn't get in.
Oh, that's even smarter. That, you might call that 3-factor or something.
Yeah.
That's good. Yeah, but anyway, something more than just a password is important. All right. Then you can consider how you build your software. This is another issue, and we're talking about it in the web app security class. You have a web front end, which is how the application is presented. Then you got the code that goes your business logic and the back-end databases, and all 3 of these things can have flaws, but the most common flaws are logic flaws, like SQL injection. SQL injection is not a bug that you can fix. It's everything running as intended. The application wanted to take the name and password from the user, and then it wanted to send a query to the database that would see if the name and password are correct. So the SQL server is running correctly, receiving a query and giving the answer. The web is running correctly, taking in a name and password and sending it up there, but nobody thought about how what it says over here might be misunderstood by the next device in line, and so a correctly formatted query will be misinterpreted at the other end and do something evil. And that's usually what happens. But anyway, you do have several layers here, and in an idyllic, perfect world where people did the right thing, each one of these pieces of software would be designed with security in mind, considering that whatever you get from the other piece could be malicious, and whatever you're passing on to the next piece might be malicious, and you should be carefully filtering what comes in and filtering what goes out from machine to machine, from process to process. But very few people are willing to do that because it's pretty difficult and painful, and that's why we have so many flaws. So the DMZ is the term for a semi-trusted region at the edge of your network where you let more people in than you would let in the private stuff. So like I say, typically put your web and email server here, and there's really nothing blocking it from the internet except a router and maybe a stateless firewall, just something that blocks obvious attack traffic like DDoS or something. And this is your public stuff, but you know that people all over the world are on these servers, and they're probably going to get hacked now and then. So you don't trust this stuff, and you don't put your secrets there. You put your secrets in a more trusted network here with your domain controller, your database server, and you have another layer of filtering, and you try to make sure that nobody gets in here except real company employees VPNing in. And that's the game. So you have layers of security. And I think this is definitely applicable to CCDC because you know they're going to be attacking you, and you know they already have backdoors on some of the machines, and putting some kind of filtering between them would probably slow down attacks. Yeah?
So we are allowed to bring physical devices to the competitions?
I don't think so. But you can install software and stuff. You can, and you have routers and stuff you can configure. So, yeah.
What
Any,
was
yeah.
CCDC?
TCDC is the main contest that we're preparing for, the Collegiate Cyber Defense Competition.
Yes.
And it's the cool thing about it is you defend a network. It's just like you might have in a small company, you get given a network that is set up wrong by somebody else. And it's already running services, and you have to keep the services up and protect it from attackers, even though it's already a mess when you get there. Which is, I think, the way the real world really is. They fired the previous idiots, they bring you in, they say, figure it out and make it better. And don't stop business while you're doing that. So, yeah, there's the book's picture of this. Here's the example border router, bringing in your packets. You have some filtering here, which goes to this screen subnet, which you might call a DMZ. Well, you call it. And a screen subnet is an area with some filtering, and then you have an internal network with more strict filtering. Typically, only employees coming with valid VPN credentials can get to the internal network. But this subnet here is only filtered to a lesser extent, and that might be where you put your web server and email server. And Ben told me about this. He says this is what they use at Uber, Phantom. And I signed up for it and tried to get it. Phantom is more than an IPS. It is like an incident response platform, and it runs on Python scripts, and you can customize them. However, I wanted to write a project on it, and I'm finding it a little daunting. You have to email them and get permission to download it, and then they tell you should deploy it as a virtual appliance, and you must give it at least a 500 gig disk, 4 gigs of RAM, and a dedicated processor. So I'm thinking, this is not something I'm just going to run on this in a VM like I do most things and play with. But so I'm going to see if I can run it in a smaller way and get some kind of project working on it, or get it to do something simple. But this is what they use at big companies, and this can do all the good stuff we're talking about. Scan for compromised machines, see attacks in progress, block them in progress, and all that jazz. And apparently it works very well at Uber. But I don't think it's something you can reasonably deploy in like an hour-long project, so probably not directly relevant to CCDC. But if I can get any version of it working, I definitely want to throw it in forensics classes doing incident response. Yeah?
Is that a commercial product?
Yeah.
So
But there's a free version. There's a community edition, and then there's the free version. So then there's the pay version. Yeah, and so that same thing. Another one that is less daunting is Splunk. Splunk you can really install. What Splunk is like Google for network traffic. You install it on a server or run it on a virtual machine. It really doesn't require much. Then you connect it to other machines. You put agents on those machines, and they forward logs to it. It will take any kind of log, any kind of data. So you put in your firewall logs, your Apache logs, everything you got, and it just organizes them all, and then you can just run queries like you might in Google to see, and there's a query that will find VPNs, there's a query that will find SQL injection, a query that will find botnets, and there's a whole community writing interesting queries. So it's actually not too hard to use, and I do have a project someplace where you set it up and do the simple things, and that's probably something you could reasonably use in something like CCDC. Splunk. This thing here looks like it really would be way too much to set up in a contest like that, but Splunk is not that hard to set up. In fact, people that get into it, I know a guy that just routinely puts Splunk on a single Windows machine just to find problems in Windows because it's more easy than Windows Event Viewer to see what's going on once you know how to use it. So it doesn't have daunting requirements. Anyway, that's, I think, the end of this. And I'm going to stop the recording and separate it because the other recording I can't put out for a little while. Wait, what happened there? Wrong thing. Quit. It should ask me to save it. Good, it does. This is perimeter. That'll do.